Yes, good morning. My name is Noreen Parizel. I want to take you through the virtual heritage tourism and indigenous knowledge preservation using advanced computer graphics. So start by talking about the theme overview. So imagine of just looking at healing plant in a glass case. You could just take a step into a forest where it grows. You could hear the stories about it being told by people who know it, the best information about it and how it was used in ceremonies rather than just seeing it in a glass case. So this is what we are building. We are working directly with indigenous communities to use virtual reality to bring their history and wisdom to life in a way that is respectful, immersive, and powerful. It's not just a tour, it's an experience that helps you to truly understand what these indigenous communities are trying to pass on to you. In the reflection, a simple idea I picked about the last lecture is that we don't need to invent the wheel, the engine, and the GPS from scratch to build a car. So you can find the best pre-made parts and focus on assembling them into a great vehicle for your specific trip. So how does this apply to our project? The parts, other brilliant people have already built the complex software needed for 3D scanning, example Colmap or the neural radiance fields. So we don't need to create our own models from scratch. So we can use these NAF and the Colmap to help us. And our our team's genius isn't rebuilding those parts. It's in being the expert assembler. You find these best in class parts or algorithms, then we connect them together and customize them perfectly, tell our cultural stories. This saves a massive amount of time and lets us focus on what makes our project unique by using the pre-made models. Then the Hugging Face or the AI-powered smart fill. This simple idea. Think of a context-aware fill tool in Photoshop, but powered by an AI that truly understands what should be there. It does not just copy nearby pixels, it intelligently generates what is missing. What I mean is that when you 3D scan an ancient artifact or sacred cave and there might be damaged or missing sections like a hole in a rock wall. So the old way, an artist would have manually painted and guessed what was there, which is slow and might be not accurate. But uh, this Hugging Face has an AI model that can predict and tell what exactly was there and what is missing. So it has to be trained on thousands of images, for example, rock textures. I show the gap and its intelligently generates a new section that matches the surrounding area perfectly. So that's how we're going to use Hugging Face in our project. Shall not use manual methods to recreate these missing parts, but shall use this Hugging Face in our project to help us. Then the first paper I'm going to talk about is the NAF representing scenes as neural radiance fields for view synthesis. So our goal, based on this paper, is to digitally save a sacred cave. We need to capture more than just its shape. We need to save how it feels, the way light dances on wet rock, the glow of fire, the hazy air. Old methods take photos and build 3D models, but the results look like video games. Misses the soul of the place. So a new technology called the neural radiance probe changes everything. Instead of building a model, now the NAF uses a smart computer program to learn how to light learn how light works in the cave. Then we shall give this new radiance field many photos for every tiny point in the cave, and the program will learn two things: what color is the cave, and then it will learn if it's solid or empty. Is the cave empty or solid? So this is what the model will learn from our pictures. And then to show a new view, it does not show a new view, it doesn't draw a model. It imagines millions of rays of light flying through the scene, asking the program what they would hit. It combines the information just like real light to create a perfectly realistic picture. This means we can finally capture the cave's true atmosphere. We can preserve the experience of being there, like someone is actually there seeing it is just maybe an illusion and not just seeing the shape. So this list lets people from all over the world to respectfully visit and learn about this sacred space without ever damaging the real thing. So they can just look at them using our models, but without visiting the real caves. And people, they are violent, they can damage their stuff. And so we're going to go to computational problem. So to use this for a sacred cave, we break the technology into simpler parts. What we need is many photos of the place, and we need to know exactly where the camera was for each one of the photo. Then what do we get? The output. We get a magical continuous map of all the light in the scene. That's why it looks so real, unlike block 3D models. Then how does it work? Then a simple AI program learns to connect. Simple AI program learns how to connect every tiny spot in the 3D space into a color and density. It simply stays its power. It forces the AI to learn the true essence of the scene, not just memorize photos. And one of the problems we have is that it's usually very slow. It needs a lot of pictures, as I said, pictures from many angles to train this model. And the smart solution is that we won't use the old slow version. We will use a new super fast version called the Instant NGP. This lets us create these hyper-realistic models in minutes instead of days. This makes the whole project possible and practical. That's what we shall use. Then another paper is heritage recording and 3D modeling with photogrammetry and 3D scanning. And as you can see, this is the old method. This old method is the perfect pattern for the NAP. And you can see the NAP, as I talked about, is for feeling. Someone has to feel like he's in the actual place because it captures the light and the atmosphere of the whole place like a cave. Then the photogrammetry is for measuring. It creates perfectly accurate solid 3D models of objects. And for these things like sacred tool or piece of poetry, we need more than beautiful pictures. Scientists need to be able to measure it exactly, study its surface, and then even print 3D, even 3D print a copy of that tool. And this method lets us do that from simple photos. So our plan is to use both the NAF and photogrammetry. Mm, the NAF basically saves the magical feeling of the chamber, and photogrammetry for the artifacts save the exact size and shape of the objects. So you understand the difference between NAF and the photogrammetry. And this solution will save both soul and the science of the place. Yeah, using these two methods I talked about. And then shall talk about the computational problem of this paper. This technology basically solves an amazing problem: how to turn a pile of regular images or photos into a precise measurable 3D model. It works like a smart detective. It scans each photo to find thousands of unique details, like specific scratch on a rock or a corner of a painting. It then matches those same details across different photos. By seeing how the position of these details changes from photo to photo, it can triangulate their exact location, 3D space. It actually figures out where the camera was for every single picture. And this whole process is called structure from motion. Then once the once the model knows the camera positions, it can build a super detailed 3D point cloud, connect the points into a mesh like digital wireframe, then drape original photos over it to create realistic textured model. And the catch from this, it needs a lot of overlapping photos with good lighting because it uses enough features light, and it completely fails on things like mirrors or glasses because they have reflections and details are not easy to track. Imagine a mirror, the model will look at it and will see other stuff in it and it will compare them where it saw them, like I've talked about. And then why we use it with enough, why do we use photogrammetry with enough? We don't see them as rivals. They are a perfect team. So we use this method to scan objects and get their perfect measurable space, the photogrammetry. Then the NAF is used to capture light. So we combine the two to create a real atmosphere of the scene. Then we can use 3D model from this method to help train the NAF faster. This combines the best of both worlds, the accuracy of geometry and the magic of light. So we can create real exact tools so that someone can feel like this is the exact thing I'm looking at, and this is the exact thing I'm supposed to be looking at, like in physical reality, right? The virtual reality and seeing it in a more. And then the other paper is talking about the BLIP2, bootstrapping language image pre-training with frozen image encoders and large language models. You are going to think of this in this way. The NAF and the photogrammetry create 3D model. Then they answer what does it look like how does the place actually look like. But the BLIP2 understands the model. It answers what is it, what are you looking at exactly. So the BLIP2 basically looks at the model, what does model given it, and tells you what exactly it is. So the BLIP2 is like a smart assistant that can see and talk. It's built in a clever, effective way. It uses off-shelf brain that understands images. It uses off-shelf that understands images, then uses the brain that understands the language, and off-the-shelf brain that understands the language. So it can understand the image and tell you stuff about the image. So a clever small bridge called the Q-former is what we use in the BLIP2. Connects these two giants. This is the only part that needs training. You have to train the Q-former. Then what does the Q-former do? The Q-former can show you can show the Q-former a picture of a scanned artifact and ask it questions. So you just show it a picture of what you want to ask questions about. Then for it can tell you information about it. For example, how should you show it a curved tool and ask it what is this tool used for. So based on what the Q-former says, it tells you this is likely to be a healing tool and used in ceremonies, carved from oak and what it symbolizes. So why this matters for us in our project? Sorry. The the mouse just slipped and I skipped some pages, but that was basically BLIP2. It just has a key format that's going to help us to answer questions about the model or the tool you've given it. So it takes into consideration of the NAF and the photogrammetry information that are given to it. Then for it, it answers the question. Then I'll talk about the survey of augmented virtual and mixed reality for cultural heritage. And this is the part about making the experience easier and natural for people. The best graphics in the world don't matter if users feel confused or disconnected. So we need to create a new way to interact that feels right for the virtual world. This research shows us how it teaches. This research shows us how we can create an interactive model So it teaches us to use simple natural actions. Look and select. Instead of pressing a button, you can just look at an object and learn about it. Instead of pressing buttons, do this, do that, then you just look at an object and learn about it just by interacting with the model. So use your hands. Basically, you can use your hands with hand tracking. You can point or a gesture, navigate, making it feel more direct. Like imagine you don't have to press buttons around, maybe type a question to the Q former. You just point at a specific part of the maybe tool, and then this will make it easier for someone to navigate your system or the model. It will be easier to use and feel more direct. Like instead of just, typing commands, then you just point at something and then this model knows you're pointing at maybe an indigenous tool, then it just tells you about it. And then we can use the 3D sound. The narrator voice will sound like it's coming from right beside you in the space. Like you assume someone is talking to you from the avatars you're going to create. It will be like someone is really talking to you about that indigenous tool. Then this makes it more real guide is there with you instead of just looking at the artifacts there. Then our main goal is to make technology invisible. The user shouldn't have to think about controls as I talked about. They should just focus on the feeling of the sacredness of the place and understanding its cultural story. This design ensures our project is respectful and accessible by anyone and truly immersive for everyone. Yeah, so we need to remove the buttons, the what, so that users can just interact with the model just by maybe pointing gestures. When you rotate, like I want to rotate and see the other end of the artifact, so you just maybe use a gesture and then the model rotates that artifact for you to see. So then the architecture, this this part is all about how you, the person wearing the headset, is actually going to talk and interact with the virtual world. Think of this like how you talk. You don't use a keyboard or complicated menu. Instead, the system understands what you want by do what you want to do by watching your natural actions, whereby we shall use gestures. Where you're looking, if you're looking at the curved part of the cave, the system will know. So now this person looking at the curved part of the cave, so he's interested in knowing about why they carve it. So the Q form has to tell you why that place is carved and why do we create this artifact like this, the indigenous, everything about the artifact. So the this is just going to help us like in our model you're going to create so that you can be knowing some gestures simply. Then how does it answer questions someone might ask? Then the world responds to you in a smart ways. A simple label might pop up on the object you are looking at. Said maybe if the avatar is still talking and then you're interested in seeing another part, yet the avatar is still talking to you, it can just give a pop-up on the object you're looking at and you know about it as you're listening to this indigenous uh, avatar talking to you, because you won't interrupt the whole system, because for you want to imagine you are two people and then this person is still interested in hearing what the avatar is talking, and then for you you're looking at some other maybe plant or medicine. So you just see a pop-up as you wait for the healer to talk about that. So that's how it's going to work in our project. And the most important rule, uh, we don't need to break the magic. The biggest goal is to make you forget you are using technology and feel like you are truly there. That's why we are trying to make it more 3D and more realistic. So we need to make users to feel like they are really there, like in the exact place. If it's a forest, they are really there in a place where the, the artifacts are coming from. So we avoid cluttering the views with menus and buttons so that it can be just gesture based. So we need to remove all the actions. That's what this paper is initially talking about. So everything feels like natural world, like you're really there without buttons, pressing commands. Then in short, we shall make the technology invisible. The interaction is so simple and intuitive so that you can focus completely on the story and experience, making it feel sacred and real. Then on my architecture, which I created, looks like this, based on what I've read. So the goal is to create a virtual world where you can walk around, look at incredible realistic objects and places, and learn about them in a natural way, as if knowledgeable guide it with you. Yet you are talking to maybe an avatar or just looking at the place. So the first step we should need to gather real world information. This is like filmmaker going on a location to shoot footage. For objects like healing plants or a tool, we need to take hundreds of photos of it from every single angle so that the photogrammetry can work for us. And then for places like forests or a cave, we need to shoot like 360 videos so that you can capture the entire space, not just what is in front of the camera. And then for the sounds, we record the ambient noises, the birds, wind, and very importantly, we need to record people telling the stories and sharing the history of these objects and places. Exactly. Then for step two, cooking the ingredients or processing. Now we take all these photos and videos and turn them into 3D digital model. This is like a chef preparing all the ingredients before cooking the meal. Then hundreds of photos are processed by a special software that stitches them together into perfect 3D digital model of the object. You can spin around and look at it from any angle. Then the 360 videos are processed by different type of AI to create a fully 3D environment you can actually walk through in a VR. Then the audio recordings are cleaned up, remove background noises. Then step three, we shall use the large vision model, which is the smart brain. This is the magic part where we need to teach the computer what these objects are so that it can tell you about them. So we take 3D models with say specific plant and then computer takes a picture of it. We show it the picture of very smart AI image recognition program like the large vision model. Then we ask the AI specific question. This is a cultural artifact for indigenous medicine. Describe its appearance and potential use in a respective and accurate way. Then the AI generates a paragraph of text describing a plant. We can have computer voice read that text loud, create a narrational clip. Then we shall building the step four is building the vision world rendering loop. And now we take all these pieces of 3D models, the environment, the sounds, and AI generated narration and assemble them into one virtual world using game engine like Unity. We place the 3D plant model into a 3D forest environment. Then we program rules when the user looks at this plant for a few seconds, play specific sound narration we created for it. Yeah. Then we set up lightning to make it look realistic, and the program how you will move around your VR controllers. And step five is the experience and output. This is the final product. You put the VR headsets. You put on the VR headsets, then you are standing into a photorealistic forest. Hear the birds and the wind. We recorded. You see the beautiful detailed plants. You look at it curiously. After a moment, a calm, knowledgeable voice begins to speak, telling you exactly what the plant is and how it was used in traditionally. So the information comes from the AI we are trained with our prompt. So you learn to explore naturally without ever needing to click a menu. So in making it better feedback, the system can also learn from you, from the user. It can anonymously note which objects you looked at the longest. If everyone skips a certain artifact, then designers might realize the AI description isn't engaging enough and can improve the question they ask the AI. This creates a loop that makes the entire experience better over time. Yeah. So that is my. Then I forgot to talk about the in a nutshell, we shall collect real data, the 3D models. Then we use smart AI, generate descriptions of these models, then build a virtual world with these That's then the experience, and the system learns how to behave and improve. That's the overall system, as how I see it should be like. Then the ultimate goal is to make you feel like you're truly there with an invisible guide teaching you. So that was my presentation. Thank you.